I recently pulled 3 7A26 plugins from our to-be repaired pile. All three had the same major problem: they shut down the mainframe power supplies. This is usually caused by shorted tantalum bypass capacitors. This is a well-known problem in many tech instruments. The best practice is to use aluminum electrolytics as replacements. If physically possible, the replacement capacitor should have at least twice the value of the tantalums and a sufficient voltage rating. The task is to locate and replace the shorted tantalums. In the 7A26, tantalums are used to bypass the plus 15 and minus 15 volt supplies. A shorted capacitor will cause a low resistance from the points indicated here to ground. The problem may be indicated by overheated decoupling resistors or inductors. As can be seen here, two of the inductors are clearly overheated. Some mainframes have linear power supplies which will go into current limit mode. The current in this mode is high enough to overheat the decoupling parts. Other mainframes have high-efficiency switching supplies which go into a benign tick mode. This will usually not cause overheating of the decoupling parts. You can locate the suspect capacitors by referring to the schematics and parts location diagrams, but I find it's faster just to visually locate the tantalums and lift a leg on each one until the short at the plus 15 or minus 15 test points disappears. I was able to fix the shorts on 3 plugins in just a few minutes each using the visual technique. On one plugin, I replaced 2 tantalums, and the shorts on plus and minus 15 cleared. But when I inserted the plug-in and powered up the mainframe, the supplies did not come up. A third tantalum, now exposed to full voltage, decided to fail. Again, I was able to locate it quickly using the visual method. The 3 replacements are shown here. When beginning to calibrate the now functional plug-in, I saw this problem. The problem with this 7A26 is that I have low gain on channel 2. I set the input to 5 millivolts, and I have a 20 millivolt input, and I should be able to use this by pushing in the variable until it engages with the gain setting control. Should be able to adjust it to four divisions exactly, but about 3.8 won't go. For comparison, channel 1 I can easily adjust it below and above 4 divisions with considerably more range. So the problem is partly the range of the gain control. When I was making this video, I should have noticed that the rotation of the calibration control was considerably less than it should have been. I spent an embarrassing amount of time looking for an electrical cause for the problem. If you watched my previous 7A26 repair video, that problem was caused by an overheated resistor which changed values, so I assumed that would be the problem in this case, but it was a simple mechanical problem. I've removed the upper board or the outer board so that you can see the mechanism that is involved in calibration and variable gain setting. This is the shaft that goes out to the variable knob, and right here would be, I've taken it off, but it would be the cam for the attenuator, and also these switches on this board are the ones that set the readout levels. But the shaft goes to this little assembly here, and finally to this latching mechanism connected to the back pot. The back pot is the variable pot. When you turn the variable knob, that changes the gain in variable mode. When the knob is pushed in, say that's the normal mode, then the gain is determined by this pot, the calibration pot, as selected by this switch, which is actuated by the latching mechanism. Here is, this will be calibrated, this will be uncalibrated. And even in calibrated mode, you can turn the variable control, although it's recessed, so you normally can't get to it. But it wouldn't make any difference because the gain is set by the calibration pot. Now, in order to do calibration, Okay, notice this small cone-shaped thing. When it turns, it has a slot in it, which is just visible there. But as it turns, it does not engage the calibration pot. But when you push in the variable knob and turn it, eventually the little arm drops into that slot in the cone, and now you are turning the calibration pot. But notice that it's still also turning the variable pot. So the rotation of each pot is actually constrained by the other. So if this little arm here is not in the right position, then the rotation of the calibration pot might be again constrained by the limits on the variable pot, and that's exactly what the problem was. This mechanism was misaligned so that the calibration pot didn't have its full range. So I very carefully readjusted the position of this little arm using the set screws relative to the position of the variable pot, which was somewhat difficult to do in place. It would be easy here, obviously, but it was kind of tricky. But at least the problem turned out to be totally mechanical and not electrical.